one or two, all right, definitely two, maybe three different ways of solving equations that deal with logarithms. And what we're using here are all the same properties and procedures that we've done over the past few days. Everything we've worked with within logs. For example, the very first example I'm going to show you here is the following. Don't worry about all these words.
Don't worry there. They're like, worry about us.
But I want you to think of this. Remember,
What?
logarithms is nothing more than working with exponents. And in order to work with exponents, we have to use some properties. One of the properties that we've dealt with over the course of the past few days was this: log base b of b to the x. What did that equal? X. It equaled x, because the reason it equaled x because these bases were the same. So what happens now is that we're going to try our best to try and get, when we have equations like this, to get a common base. That's one of the methods that we use to solve. So if I'm looking at the problem I have here, I have things written up in terms of a 4 and a base of 8. How can I rewrite a 4 and rewrite an 8 to have a common base? 2. I can write it as 2 squared and 2 to the third. You guys agree? Here's what happens. When I get a common base here, I get 2 squared, that's 3x, equals 2 cubed times the x plus 1. Everybody all right with that? Now, whenever you're working with an equation, what you do to one side, you have to do
To the other side.
correct. And that's how these things stay balanced. Now, what I'm going to do to one side here is I'm going to log it. I'm going to log it. What's this base? I'm going to set this to the log base 2 on both sides. Exactly. Watch what happens. Are these two bases the same? What happens to the exponents then? They fall. So what's 2 times 3x? What I have done there is I've eliminated the bases by taking the log of both sides. By taking the logs of both sides of that base, it drops the exponents down. So now I get 3x is 3, x is 1. And that's it. All right, and that's it. Now, how can I check to see if I did that right? Yeah, substitute back in your computer. I can substitute that back into my computer, my calculator, to see if it worked. What's 4 cubed? Very good. What's 8 squared? Very good. And it worked. All right, you okay?
Yeah.
All right. Let's try another one. Again, what I want to do here is I want to try to get a common base. I have 9 to the 2x equals 3 to the x minus 6.
3 to the 4. Yeah.
Oh, I'm like, what? Yes, you're right. I need to change that 9 to have a common base of the 3. So how can I rewrite 9? 3 squared. So on the left-hand side, can I write it as 3 to the 4x then? Everybody okay with that?
Yeah.
What log base do I have to take on both sides then? Log base 3.
Do you have to show this step?
No. And that was the point I'm getting at. At this point in time then, once you have the same common bases, I am perfectly fine with you guys just going to the next step. Because that's what you're doing. Once you get that common base, it'll work out just fine. Now the one thing I will tell you is a lot of times when you're rewriting your bases, Sometimes people, when you, let's say you had to distribute to the other exponent, people forget to send it to the other term. Just be careful when you set that up. That's a very common mistake, okay? What is x going to equal here? How would you check your work? We're not doing electrical work. We're substituting, okay? Again, does everybody kind of understand why I kept going over log rules? This is the reason why we're able to solve equations. Because it's fun. We're rolling right along now with logs.
That's
Who can do a cricket imitation?
How many times do you use this? Do you say it in every class?
No.
You made something you terrible.
2 to the x equals 7.
No one knows.
Anyway, 2 to the x equals 7. Now, in this case here, in order to get that exponent off the 2, what would I have to take on the left-hand side? Log base. Okay. So if I take log base 2 on this side, what do I have to do to the other side?
Log base 2.
Log base 2. So right now, the left side becomes x. The right side is log base 2 of 7. This is where it comes into how do I find some numerical value. Again, 2 to some power equals 7. Well, that means it's going to be less than 2 cubed, because 2 cubed is 8. But it's greater than 2 squared, so somewhere between 2 and 3. We just got to figure out that value. So here's what happens. We have to use what's called a change of base. This is a very, very easy process to do. Take a deep breath. Log of 7 divided by log of 2. No, it's actually 2 different values. Okay? In your calculator, when you type in they're out. Log of 7. See how it opens up a parenthesis? Just close it and divide it by the log of 2. Close the parenthesis, hit enter. There's your answer. 2.81.
Oh, that's what x equals?
Yep.
That's great.
All you have to do.
So your x equals 2.81.
Yep.
They have 44 on iron pants. Why?
I got 33.
There's your answer.
You got 43.
Again, what's happening here, if I look at, oops.
That's crazy. They were getting
5 to the x equals 8. 5 to what power is going to give me 8? Well, how do I get that exponent to fall to the ground? 1.5. Log base 5. So x is going to equal log base 5 of 8. Now, there is a way to change the base in the calculator to actually type in a base 5 if you'd like. It just takes a whole lot of other buttons to press to get there. I've always found that it's easier just to type in the change of base. If I'm not mistaken, oh, what is it? Alpha window?
No, you go to math. Yeah, you go to math. Go to math and scroll. Well, the shortcut would be alpha window 5.
Yeah. If you type in alpha window 5
I got one.
in your calculator, if you go alpha window 5, you can actually type that in exactly the way it looks.
What?
Log base 5 of 8 and hit enter. There's your answer.
I like the other way better.
The change base?
Yeah.
It's fine. I mean, either one is fine. I like doing the change base one since I think it's a little bit easier. Yes, ma'am.
Okay, I know I'm kind of backtracking divided by times 2.
That's a divide.
Yeah, why did?
That's how we change the base. Whenever our logarithms in our calculators are all in base 10, in order to change the base to get the actual value for what it's going to occur at, you have to do that what's called change of base formula. You take the log of whatever it is, divide by the log of the base.
Doesn't log say 7 to 2
Log base 2 is 7? Yeah, it should be the same. You say log. All right.
Oh, so it's just you did that instead of going to
Okay. All right, let's take it a step further. Take it another step. Again, we have a multi-step problem dealing with exponents. Think about it in terms of order of operations. Yeah. Lunch detention, 32 minute targets.
Probably.
Again, if I'm going to deal with this in terms of order of operations, what would you have to move first? Okay, how do you move it? Okay, so I have 10 to the 2x minus 3 equals 17. Now what? You log up. Do I have to say base 10? Nope. I just log both sides, so I get 2x minus 3 is the log of 17. Now, log of 17 is some crummy looking decimal.
Yes.
So here's what we do. In order to continue solving for x, what do you have to move next? Okay, and then divide by 2. So x is going to wind up equaling the log of 17 minus 3 all over 2. In your calculator, since your calculator is set up as a base 10, when you hit the log button, what opens? What do you have to close?
17 minus.
Close the parentheses. All right? It's not going to be log of 20, or log of 14, excuse me. So hit log of 17, close the parentheses, minus 3, hit enter. Divided by 2, hit enter. Negative 0.88. Did I write? Oh, I'm sorry, it is plus 3, my bad. No wonder. Algebra is hard.
It is. This is very hard.
What if you were just to put it all in the fraction?
Does that, I think it works.
It's close, but it's not similar. Like if you did it the wrong way, I got 8.4 instead of 8.
You still have to close the parentheses.
Yeah.
It's the same answer. What she was asking, if you put it in with the fraction bar, you're going to get the same answer, guys. You just have to remember to close that parentheses on the logarithm. If you don't close that parentheses, bad things, man. Bad things.
Very bad.
Okay? Questions? Let me give you a few of these to try for tonight.
Mr. Murphy, like I did it how like
What?
I just did log of 17 divided by log of 1.23 and then added 3.
You should get the same answer because what's the log base 10 of 10? It's 1. So what you did is you just divided the log of 17 by 1. So yeah, you'll get the same answer.
What about some video games which are boyfriends?
What's that, Doug?
Beating up zombies.
Guys, come on, come on.
Newton's law.
The what? Newton's law?
Yeah.
Or Newton's log?
Newton's law
Newton sat on a log.
Probably wrote his law. I thought Newton's law was science. It's like
It was a joke because Newton with the apple was next to a tree was made of a log.
Isn't that with the balls and then you like let one go and then
That's perpetual motion.
yeah, but Newton.
That's some object states. That's transfer or something.
Yeah. I did that in 8th grade.
That's pretty
I was
cool.
so proud of you.
Section 8.6.
No, wait, is it? Log of 7. You don't add those. It doesn't work like that. Log of 7.
Do those, please, ladies and gentlemen. Yeah, it gets a little bit more complex tomorrow. We'll wind up with some. There are some fancier things we're gonna do. it worked out real nice that you guys were able to fly through the first few sections of this chapter. It allows us to slow down when things get a little bit more difficult. Are you taking like a macro picture of that?
It's about time, guys. Saying it didn't change the answer. Yeah, because they didn't know. I know.
Yeah, I'm pretty sure you've never seen someone make it.